Algebra 1 Common Core, Unit 8, Section 5, Vertex Form. So now that you're experts in completing the square, one of the very useful applications of it is converting your quadratic equations we've been working with into what's called vertex form. Now, what exactly is vertex form? Well, vertex form looks like this. That's different than the traditional form you're used to, which is ax squared plus bx plus c. For example, you're used to looking at quadratics like this. Well, in vertex form, quadratics look like this. And, the reason why it's called vertex form is you could just kind of look at it and tell what the vertex is. Using this, for example, down here. So for vertex form, I also often refer to it as transformation form. Because if you remember the transformations, like this is a dilation, this means left 5 and down 4. Well, the number inside the parentheses and the number after the parentheses, which corresponds to your horizontal translation and your vertical translation, like this means right 5, down 4. Remember, plus inside actually means left and minus means right. But on the outside, plus is up, minus is down. But anyways, this is your side-to-side translation, your up-down translation. Well, those two numbers correspond to what your vertex is. They're actually giving you directions to the vertex from the point from the origin, 0, 0. So if we go left 5, down 4, we get to the point negative 5, 4. And that's the vertex of this quadratic. Like if we type this quadratic into our calculator or in Desmos, we'll see that the vertex is negative 5, negative 4. That's the turning point. In this case, it'd be a minimum value. So, the trick here is recognizing that it's the two numbers here and here make up your vertex. But it's the opposite sign you see inside the parentheses. It's the opposite sign because, remember, plus actually means left and minus means right. So you got to take the opposite sign of the number inside the parentheses. But the number, and that's your x value of the vertex. The number after the parentheses, you keep that sign. It is its true sign because that does mean down 4, and that's your y value. So very simply, in vertex form, what is the vertex? This one, again, it's the opposite sign of what you see in the parentheses, so negative 5, and the true sign after the parentheses, negative 5, 2. Here, it's the opposite sign inside the parentheses, and then the true sign after the parentheses. Oops. Here we see it's the opposite. So there's a number out front here. What is that negative 2? Well, that's a dilation, and the fact that it's negative, it's flipped upside down. So it'll look like a negative parabola, like an N instead of a U. Well, that has to do with reflections and dilations. That actually doesn't change the vertex. So our vertex still is just the numbers here and here, but it's the opposite sign inside the parentheses and the true sign after the parentheses. And so those are the vertex of these parabolas, and you could easily check it. Like I already have these typed into Desmos. If we look at this first one, we think the vertex is negative 5, 2. Well, if you take a look at this one typed into Desmos, negative 5, 2 is left 5, up 2. This is the point negative 5, 2. If we take a look at this second one, we think it's positive 3, negative 5. Positive 3, negative 5. Yep, that's where the vertex is. Now, this one, we think the vertex was negative 6, negative 1. Remember, it's negative 6, negative 1. And we see this as negative 6, negative 1. That's what that vertex is. And again, the reason why it's an upside down parabola, a negative parabola, is because of the negative in front of the 2. And it's a little bit more narrower. That's because of the 2 in front of it. So the negative flips it upside down. The 2 makes it narrower. The 6 in here still means left 6 and minus 1. But those two numbers together, that's how we get our vertex there. All right, so one of the tasks here, I mentioned completing the square, is usually you don't get quadratics in vertex form. Typically, you get them in standard form, like this, like we've been working with all year. And so we can use completing the square to convert it into vertex form. And so if we take a look at this example here, that's typed out for us. Here's 8x plus 13. Just want to make sure it's different than what's down there. So here's the original quadratic. And so what you do is follow the process of completing the square. First, drop the y and set it equal to 0. And then if you remember for completing the square, then we move the constant over, so we set it equal to negative 13. And then we add 16 on both sides, and that comes from your b term divided by 2 is 4 squared is 16. Then you factor that on the left and combine it on the right. Then so what we would do typically is like square root both sides, get the whole plus minus, but we want to stop right there in completing the square because we're not trying to solve for x, we're trying to get what's called vertex form. So once you get down to the binomial squared equals number, simply move that number back over. So move that, minus that number back over, minus 3, and set it back equal to 0, and then set it back equal to y. And so there's your vertex form, x plus 4 squared minus 3. So it's kind of like halfway through completing the square, and you stop right before you square root both sides. Because you're not trying to get x alone. You're just trying to change it. So we'll use an example here, x squared minus 8x plus 19. Again, I have this typed into Desmos already for us. So here's x squared minus 8x plus 19. And I could see in Desmos my vertex is this point. Looks like 4, 3. 4, 3. So I kind of know the answer, which is helpful. So 4, 3 is what I'm hoping to get for a vertex. So the first step, again, now this one's already set equal to 0 for us, is move that constant over. So we're going to make it x squared minus 8x equals negative 19, right? Because I have to minus 19 to get it over there. Then we're going to add something to both sides. That something comes from our b term. That's our 8 here. Divide it by 2 is negative 4. Squared is 16. Just like in that last example, 16, 16. On the left, we factor it. And you could write the double parentheses if you want, but the shortcut is recognizing that it's going to be the same parenthesis twice, so we write it as a single parenthesis squared. And it's, what multiplies 16 adds to negative 8 is negative 4 and negative 4. And the shortcut to that is recognizing that it's always half a b. And that equals, this combines to be a negative 3. Now, if we were continuing to complete the square, we would square root both sides, but we're going to stop there. We're done completing the square. Now we reset it equal to 0. So bring this number back over. Because it's negative, I'd have to add 3 to both sides, making it x minus 4 squared plus 3 equals 0. And then lastly, instead of having it equal to 0, put it back equal to y. Y equals x minus 4 squared plus 3. And then you can look at this and say, all right, what's the vertex? Well, the vertex is the opposite sign we see inside. So that negative 4 is really a positive 4. And the true sign outside. So 4, 3. And what did we say we thought the vertex was? 4, 3. So that's what we're doing here, is being able to get it into a vertex form. Remember, this is also like a transformation form. Like that minus 4 means right 4. Right? Right 4 and up 3. Right? The minus inside means right. The plus outside means up. Well, that's what's happened. From the origin, how do I get to the vertex? I go to the right 4 and up 3. That brings me to the point 4, 3. All right, this can get a little bit trickier in the cases where we have a number in front of x squared. So let me show you that really quick. So on my next page here, I have an example of a quadratic where there's a number in front of x squared. And I don't think we've done any examples with completing this square where there's a number in front of x squared. And I'm not going to ask you to do that as far as solving for x, but I might ask you for a vertex form question where there's a number in front of x squared. If I had to solve for x here, it might even just be easier to do the quadratic form. But the process for completing a square or vertex form when there's a number in front of x squared starts off still the same way. You move the constant over. Then you need to factor out that number that's in front of x squared as a GCF. So I took out that 3 just on the left side. Take out the 3. What's left over is x squared minus 4x. Then we go through the process of completing the square just in here. Think of this as your b term. So that divided by 2 squared, that's what we would add to both sides, right? So divided by 2 is negative 2, squared is 4. But we actually don't add 4 on the right side, we add 12. And where does that come from? It comes from the times 3 that we have out here and the plus 4 we have in here. And that's how we get the 12. Then you still factor that like you normally do, but just keep the 3 on the outside. Right? That's how we're getting this factors to x minus 2 squared. And simplify the right side to negative 1. And then again, we're not solving for 0. We're vertex form, so we move that number back over before we would square root and get that vertex form like that. So let me show this to you one more time. This is a little bit more complicated because of that added GCF piece. But let me show it to you. So first step is I might as well move that constant over to begin. So minus 17 on both sides. Then I want to GCF the number in front of x squared because I don't want a number in front of x squared. So plus 6x equals negative 17. Then just within here, what would I add? So x squared plus 6x plus, there's my b term, divided by 2 is 3 squared is 9. But I actually don't add 9 to the other side. I add 2 times that 9 because if I were to distribute, it'd be 2 times 9. So I add 18 to both sides. Factor the left is going to be x plus 3 squared. Again, just ignore the 2 out front for a second and just factor it just like normal, completing the square. Combine this like normal, 1. And then bring that 1 back over, and I'll get this in vertex form, y equals 2 times x plus 3 squared, and moving that positive 1 over makes it a minus 1. And my vertex here is going to be the point opposite sign inside, correct sign outside. Remember the number in front of the parentheses, that has to do with the dilation. So that's going to make it more narrower, but it's not going to change the vertex. And again, I can confirm this in Desmos here that my, turn that one off, my vertex is negative 3, negative 1. And that's what we see here, negative 3, negative 1. All right, guys, so that's it for using completing the square to get into vertex form. See ya.